So continuing here with our 3.6 notes. Okay, limits at infinity. So we already have done like limits that approach infinity or negative infinity, right? And those were our vertical asymptotes. Okay, now we're going to be talking about if we take the limit as we go out to infinity. So if we make our x value infinitely large, or go to negative infinity and make our x value infinitely negative, okay, what that goes to. And that's going to be our horizontal asymptote. Okay, so if I go out to the right and it approaches this number here, L1, that's going to be a horizontal asymptote at L1. If I go to the left infinitely and it's approaching this value up here called L2 in this picture, that's going to be a horizontal asymptote. How many horizontal asymptotes can a graph have? 2. Does it always have to have 2? No, it can have at most 2, so it can have 2, 1, or no horizontal asymptotes. Okay, so let's talk through the top here. Alright, so limits at infinity, it specifies a finite value, which means like a number. Okay, it's not infinite. Approached by a function as x goes to infinity or as x goes to negative infinity. So let's try to find this limit. As x goes to infinity, I think the easier way to do this one is just to leave it the way it is. If x goes to infinity, wouldn't this be 5 over infinity squared? Which is 5 over infinity. What would that go to? Something really, really small, right? If this is 5 over the biggest thing possible, so this is going to go to 0. Whoops, I wanted to write 0. Here we go. We'll try again. Okay, so if this is infinity, this whole thing here goes to 0. So what's this limit going to be? 2. Does that make sense to everybody? So we'll just kind of write that off to the side here. So this would equal 2 plus 5 over infinity, which is the same thing as 2 plus 0, which is just 2. Okay, so that's the easier way, I think, to do problems that look exactly like this. Problem is, a lot of times they're going to look more like these. So how could I get this one to look more like the bottom ones? Common denominator I could do, right? So I'm just going to make this small here. So if I get a common denominator, my common denominator would be x squared, so this would become 2x squared plus 5 on top. So I've got the limit as x goes to infinity of 2x squared plus 5 over x squared. Is everyone okay with that? Okay, now something that you might want to write somewhere in your notes is as x goes to infinity or negative infinity, only the highest degree terms are considered. So let's say only highest degree terms are considered. As x goes to plus or minus infinity. Okay, all other terms are considered insignificant because if we're going to infinity, won't the highest degree term overpower the rest? Like even if I had, let's say, x squared minus x, is this going to end up going to infinity or negative infinity? It would go to infinity, right? Because this is going to be bigger than this infinity. Does that make sense? Okay, so the largest degree term overpowers the rest. So we only look at the largest degree term. So in this case here, what term is insignificant? The 5, right? So I would have like 2x squared over x squared, which would give me 2. So do you see how I get the same answer for both of those? So this would equal, oh, it keeps jumping back. So this would equal 2 here. So questions on that? So do you see how you can do it either way? You should get the same answer. Okay, let's go ahead and look down here then. Okay, so we talked about this definition of a horizontal asymptote. This is the limit as x goes to infinity of our function equals L1. So as we go to the right forever, do you see how it's approaching this L1? And as we go to the left forever, it's approaching L2. So L1 and L2 are both considered horizontal asymptotes. Okay? So if we're trying to find horizontal asymptotes, you take the limit as x goes to infinity, and you take the limit as x goes to negative infinity. Whatever value you get for those are your horizontal asymptotes. Okay? So any questions on that concept? We're going to go ahead and try to find all horizontal asymptotes. So let's just do this first one here. What I'm going to do with this is I'm going to take the limit as I go to infinity. So we're going to take the limit as x goes to infinity of, I'm just going to say f of x, that exact function. Now we're thinking about this concept here. Only the highest degree terms are considered. So what's the highest degree? The 4x squared, right? That's really the only thing that matters in this case. So everything else is insignificant, right? So the numerator, do I even have anything? No. So this is going to be like 0 over, whoops, I should write the limit again. So this would be like the limit as x goes to infinity of 0 over 4x squared, which just gives me what? 0. Okay, would this change anything if I went to negative infinity instead? No, so I don't need to do both in this case because they're going to both give me the same, okay? So same for negative infinity, we'll just write that here. Okay, so for this here, this would be my horizontal asymptote here, right? Yep. So if I actually graph that, we'll graph it here and look at it. So I'm going to say horizontal asymptote is at y equals 0. And as we said, okay, if I go to infinity, it goes to 0. If I go to negative infinity, it goes to 0. So my graph should support that. So go ahead and get your calculator out and put that equation in your y equals, and we'll look at it here. Okay, so I throw this equation into my y equals, and then I just try to find a good window so I can actually see what's going on. So I went negative 10 to 10 on my x's, and I zoomed way in on my y so I could see the graph here. So it comes up, and as I'm going out to infinity, does it look like it's approaching 0? Yeah, and as I go out to negative infinity, does it look like it's approaching 0? Yeah. Okay, now a question that a lot of people have is, if there's a horizontal asymptote here, it crosses, doesn't it? Is it okay for it to cross a horizontal asymptote? Yes. Is it okay for it to cross a vertical asymptote? No. And how I remember that, if you've had me before, you might know. Okay, vertical asymptote is VA, right? We're all into texting and stuff, right? VA doesn't stand for vertical asymptote. Okay, it stands for very aggressive. Okay, you don't want to touch them. They bite, I don't know. Okay? It does too make sense. Horizontal asymptotes, that stands for not very aggressive. Okay. Horizontal asymptotes you can actually cross as many times as you want to. They're just very, like, non-aggressive. What? No, we gotta come up with something that starts with an H. I just don't know very many words. Okay. Okay, so a horizontal asymptote can be crossed, vertical asymptotes can't, okay? Now, a horizontal asymptote can actually be crossed an infinite number of times if you have, just for your future reference, okay? So you're not like, oh, that's not one. As long as if we go out to infinity, it approaches that value, it's going to be a horizontal asymptote. So there are some graphs that kind of oscillate and go like this. They look kind of like sine and cosine. Remember that damped harmonic motion that goes like this? Okay, this red line here gets closer and closer to that red line. It's actually a horizontal asymptote. Does that make sense? Okay, so that could happen. I mean, it's not going to happen often or anything. Let's go ahead and try this one now. Okay, just trying to find the horizontal asymptotes. We won't graph every single one, but if you're not sure if your answer is right, you can always graph it to check. Okay, So let's try this next one here. What are the significant pieces? The 2x squared and the 4x squared. So if I'm taking the limit as x goes to infinity, we'll start with, of my f of x, that's going to be the same as taking the limit as x goes to infinity of the 2x squared over 4x squared, which is going to give me what? 1/2. I don't even really have to worry about the infinity part for that. So this tells me, is this going to be the same for negative infinity? Yeah. So I don't have to do that separately. So my horizontal asymptote is where? It's at 1/2. What's the equation for it? Y equals. Okay. If it's vertical, it's x equals because it cuts through the x-axis. If it's horizontal, it's y equals because it cuts through the y-axis. So this would be y equals 1/2. So if you looked at that graph, that's what it should be approaching as it goes to infinity and to negative infinity. So any questions? Okay, I'll let you guys try the next one there. I'm already hearing some ideas. Maybe your ideas are right. Okay, it's the same for positive infinity and negative infinity if it's like you don't have to plug it in, okay? For this one here, we'll have to. Okay, so you'll see an example where we have to. Okay, this one, if I take the limit as x goes to infinity of my f of x, what is the significant piece? The 2x cubed. So the denominator is what? 0. So can I take the limit of 2x cubed over 0? No, that's undefined, right? So let's just say undefined for this. Would it be any different if I plugged in negative infinity? No. So we're going to say same for negative infinity. So what does that tell me about horizontal asymptotes? There's none. So we'll say no horizontal asymptotes. And if you're not sure, you can always, graph it and look to see if it looks like there's one or not. Okay, let's try the last one here. Okay, the last one. What would be my significant piece here? You kind of have to be careful with this one because there's a square root. Just x, because this is x here, right? And isn't the square root of x squared x? Okay, so if I take the limit as we go to infinity for this one, I'm just looking at the limit as I go to infinity of x over square root of x. Now here, this might be a little confusing, so just bear with me for a second. Okay, the infinity one isn't too bad, right? If it's positive, if I take it out of the square root, whoops, this was x squared, wasn't it? Sorry about that. There we go. If I take it out of the square root, it's just x, isn't it? Okay, so I end up with what for my horizontal? 1, right? Because it's x over x. That makes sense? Now, a lot of people would be like, oh, it's going to be the same for negative infinity. It's actually different here, and we'll verify with our graph in a second. Okay, if I go to negative infinity, I still would have x over the square root of x squared, right? Now, let's think about this for a second. If I'm going to negative infinity, I know my x is what? Negative, right? So if my x is negative, think about this as like negative 3 squared. It's still the square root of 9, right? But when I pull it out of there, it's actually negative 3. Right, the top, okay, sorry. This would actually be 3, right? But the top would be a negative value. So do you see how you're going to end up with, instead of 1, you'd end up with -1? Okay, I know that concept's a little confusing. Okay, but if it's negative values and you have a square root, it's going to actually be the opposite. And you can always verify with your graph if you're doing your homework and you're not getting the same answer. Okay, so we get -1. So where are my horizontal asymptotes at? 1 and -1. And what's the equation? Because I have to write them as equations. Y equals 1 and y equals -1. You could put y equals plus or minus 1. Yep, that would just imply that it's both. Okay, so any questions there? Okay, now a little bit of a way to cheat to get these if you have your calculator. So you could, check your answers. I know when I say cheat, everyone's like, oh, listen. Good, let's listen. I'll just pretend like we're cheating when we're just doing math. Okay, let's throw this equation into our y equals. So we have x over the square root of x squared plus 1. And I'll probably have to switch my window here. It didn't square root, did it? Let's just start over. Okay, so I would say by looking at this graph, as we're approaching infinity, it looks like it's going to 1, so that looks right, and negative infinity looks like it's going to -1. What I do just to find what this is approaching, because sometimes it's kind of hard to tell, because maybe it comes way up and then starts to come down. It's like, is it approaching 1, or is it approaching 1.1? Like, it's hard to tell what it's approaching. What you can do is go to your table and, start wherever you want, and go by something ridiculously large. Because if I go to my table, then it tells you what it's approaching, okay? Because as it gets so big, your calculator can't round something to, a million decimal places. So I just go by something ridiculously large. So you can see as you get to really, really big values, the y value is really, really close to 1. Okay, so close to 1 that your calculator rounds it to 1. And as you go to really, really big negative values, it goes to -1. So if you do have your calculator, you can use that to help you with your answers. Or if you need to check your answers, that's a way to check your answers. Okay? Graph and table it. Yep, and if you look at the graph, you should notice, it looks like it's 1 and -1. Your table just kind of confirms that for you. Okay? So any questions on that? You're not going to always have your calculator, okay, for that reason. Okay, then there's your homework.